Here is your promised Unit 7 4.0 practice video. These questions are off the 4.0 practice sheet that was given to you yesterday by the sub, or you could have picked one up off my desk today. Okay, on this question you're asked to divide by x squared minus 7x plus 5. We can't use synthetic division on this because we can only use synthetic division when we're dividing by a linear thing. So if it were x plus or minus a number, then we could use synthetic division, but since it's a quadratic, we can't. So we're going to set this up like a long division problem, like we would in elementary school. So we're dividing by x squared minus 7x plus 5, so that's going to go on the outside of our division. Not 5, sorry. And we're dividing the 6x to the 4th. I'm going to put in 0x cubed as a placeholder because you want each power represented. Okay, so the first thing we're going to do is we're going to take this and divide it by x squared. So 6x to the 4th divided by x squared is 6x squared. And then we're going to multiply 6x squared times each one of these things. So 6x squared times x squared is 6x to the 4th. 6x squared times negative 7x is negative 46, or not 46, sorry, 42 x cubed, and 6x squared times 5 is 30x squared. Then we're going to subtract this new polynomial. Well, subtracting really just means we're changing the signs and adding, so that's what I'm going to do. Change all the signs and then add. These should always cancel. I get 42x cubed minus 23x squared. And I'm going to bring this down, so minus 3x. And really, you can bring down the 10 too if you want. You just don't have to. Okay, and then we are going to divide this by x squared. So 42x cubed divided by x squared would be 42x. So plus 42x. And then I'm going to multiply 42x by each one of these things. So 42x times x squared is 42x cubed. 42x times negative 7x would be... Okay, so 42 times negative 7x is negative 294x squared. And then 42 times 5 is 210x. So plus 210x. And once again, we're going to change all of our signs and add. These cancel. 294x squared plus negative 23x squared is 271x squared. And then negative 210 and negative 3 would be negative 213x. Bring down this plus 10. And we're going to divide 271x squared divided by x squared. So plus 271. And then we're going to do the same thing that we've been doing. We're going to multiply 271 times x squared. Keep writing ones instead of sevens. Sorry about that. And then 271 times negative 7x, which would be negative 1,897x. This just keeps getting uglier and uglier. Sorry, guys. And then 271 times 5 would be 1,355. And then change all of our signs and add. These cancel. And we have 1,684x and negative 1345. And this is going to be our remainder. And it's our remainder because we can't divide by x squared anymore. So we're just going to put plus, then our remainder over what we were dividing by. And that's it for that problem. Okay, so for this problem, this is actually really similar to the problems that you did at the 3.0 level where you're writing polynomial functions. The only difference is that your point is kind of disguised. So instead of just telling you the point is 2, negative 4, it gives you this. Well, this says if we input 2, and remember our input is our x, then our output is negative 4. So this is our xy. So this says that the point is 2, negative 4. So we're going to do the exact same thing that we do at the 3.0 level. We have three zeros, so we're going to have 3 factors. And then we're going to input our x and y. Simplify our parentheses. Multiply -1 times -3 times 3. So what is that? 9. And then divide by 9. And so our a is -4/9. And we just plug that in for a. And we'll just leave this in standard form. And we're done. Okay, so this problem is similar to the ones at the 3.0 level. It's just an x to the 4th instead of x cubed, so there's an extra step. And also you won't be able to solve this one by factoring, so that adds another dimension to it as well. So the first thing we're going to do is we're going to list out our possible rational zeros. We're using the P over Q theorem. So our P is going to be factors of 198. So there's quite a few of them. So I'll just list those out for you. Okay, and then the Q would be factors of 1, which are just 1 and -1, so I'm not going to take the time to show dividing that out each time. Hopefully we understand that dividing by 1 won't change any of these values. So the next thing we want to do is we want to find some actual zeros. So we could just start at 1 and then test and test and test and test until we find one that works. But when you have a ton of possible zeros like this, I'm going to tell you the easiest thing to do is type this into your calculator and your y equals and look at the graph of it, because if you remember, solutions and x-intercepts are the exact same thing. So you can just look where it crosses the x-axis and then you can start there. So when I look at it, I see that it crosses at -3. So I'm just going to go ahead and divide by -3. Okay. Like I did something wrong there, so let me look at this really quick. Okay, maybe I'm not doing something wrong. Okay, -156. Sorry, I was second guessing myself there. -66 and then +198. So then we get our 0 like we're looking for. And then we're left with the function x cubed minus 13x squared plus 52 minus 66. Okay, so here's the cool thing about these. So we can't solve this yet because we only know how to solve quadratics, and so really we have to divide by one more 0. So when I looked at my graph, I also saw that +3 was a 0, but instead of just going into these numbers like I did on that first one, I can just go into these. So I'm just going to use these new coefficients and I'm going to divide by +3, and what's going to happen is it's going to take it down to the quadratic range so that I can actually solve it. So now I'm left with x squared minus 10x plus 22. So my complete factorization is this, and then the factor that I get from this number right here, which would be x minus 3, and then the factor that I get from this number right here, which would be x plus 3. So for question B, this would be my complete factorization of this polynomial. So I already have two of my zeros, 3 and -3, and then I'm told to solve, so I'm going to solve this. Now I can't solve it by factoring because there's no two numbers that multiply together to give me 22 and add together to give me -10, so I'm going to solve by completing the square. Okay, so first thing I'm going to do is I'm going to move that 22 to the other side. Then I'm going to half it, square it, add it. So half of 10 is 5, squared is 25, so I'm going to add 25 to both sides. Factor this left side. Square root And then I'm going to add 5 to both sides. And so my solutions are 3, -3, and then 5 plus or minus root 3. So that's 4 solutions, which since it's a degree 4, that's how many we want. So that's how you would solve this. So you find one zero that works. You use those new coefficients. So we put those right here. And then we find another 0 that works. And remember, we use our calculator to help us do that by looking at the x-intercepts so that we wouldn't have to check all of the possible rational zeros that we found in A. So let me know if you have any questions over this. Hopefully this helps you guys understand the 4.0 a little bit better. Thank you. Have a good night, and I'll see you tomorrow.